Welcome back, welcome back. This is Steve Scully. I am reading through my book, the instruction manual as it is written in the cosmos. We're starting chapter 2 here, so here we go. The Universal Principle of Natural Philosophy. Section 1. How Gravity Causes Electromagnetic Fields. Electromagnetic fields are considered to be caused by charged particles as a result of the fundamental force of electromagnetism. For example, the Earth's electromagnetic field is thought to be produced by the flow of charged particles inside of the Earth. However, due to the capacity of particles to physically travel through systems which they orbit, the existence of gravitational orbital patterns in the shape of a figure 8 is recognized. As a result, the mechanism by which gravity causes electromagnetic fields is deducible. Standard models of physics describe the universe to have four fundamental forces of nature: gravity, electromagnetism, weak interaction, and strong interaction. This is inconsistent with the simplest possible description of the mechanics of the universe, which would have the fewest causes possible. Indeed, the sharpness factor with so many forces is dull. In order to address this issue, it is necessary to find the causes of the fundamental forces of nature and thereby arrive at a simpler model that more accurately describes our universe. This is achieved through a first step of connecting gravity and electromagnetism using classical mechanics. In order to do this, the previously unrecognized characteristics of the universe discussed above need to be incorporated into considerations, the first being that the universe is infinite. This consideration allows us to envisage an infinite array of particle types of different masses, from infinitesimal through infinite in mass, relative to the mass of the atoms which we use to observe our surroundings. The second consideration is that particles are capable of physically traveling through other particles, as is demonstrable in the case of neutrinos passing through the Earth. The capacity of particles in the cosmos to pass unabated through other particles is an important characteristic regarding how the universe functions, which requires necessary consideration in developing a working understanding of how electromagnetic fields are produced. With the above considerations, it is possible to arrive at a description for how gravity causes electromagnetic fields. In Principia, Newton described the laws of motion and the laws of gravity. Today, these laws are common knowledge and are the foundation of classical mechanics. However, because Isaac Newton was unaware of the capacity of particles to physically travel through other particles, he did not incorporate this characteristic into his model. Thus, he was unable to propose a mechanism through which electromagnetic fields were caused by gravity. In addition, it is important to recognize that if the universe is infinite, then this means that particles within it do not just get infinitely large, but also can be infinitely small. An entire array of ever smaller particles exist, where the largest particles of those smaller than ourselves would be what we see as the nuclei of atoms. In order to recognize the mechanism by which gravity causes electromagnetic fields, we can envision a first particle having a very small mass, m1, and a second particle having a relatively very large mass, m2, where m2 is much greater than m1. Comparatively, the particles can be considered infinitesimal and infinite, respectively. If these particles are very far apart, other forces on the small particle m1 would keep it from being pulled towards m2. However, if they are sufficiently close, then the force of gravity of the very large particle m2 on m1 would be high enough to pull the very small first particle m1 towards it, due to the inverse radius squared function of gravity, F equals g times m1 times m2 over radius squared. A unique outcome is achieved if the conditions are such that the first particle is close enough to the relatively large second particle so that it is pulled directly towards it, and it is capable of traveling through the building block components of the second particle unimpeded. In such a case, as shown in figure 3 below, the first particle is led to travel directly towards the center of gravity of the second particle. However, due to the large relative mass difference between the two systems, the very small first particle is able to then physically travel through the body of the second particle. As we see here with the dotted line arrow, the first particle is physically entering into the body of the second particle because it is capable of passing physically through the second particle. As a result, the direction of the force of gravity upon the first particle as acted upon by the second particle is then reversed due to the first particle physically traveling past the center of gravity as its momentum carries it through the center of the body of the second particle. In turn, the first particle is caused to be redirected back towards the center of gravity, as shown in figure 4. If we pause here, the circumstances of the traveling first small particle are the same but opposite to as it was initially. In the same way, after the first particle is redirected back towards the center of gravity of the second particle, it will physically travel through the body of the second particle, and the direction of the force of gravity upon the first particle is again reversed. Repetitively, this traveling through the center of gravity of the second particle by the first particle and the reversal in the direction of the force of gravity upon the first particle occurs. This results in a figure 8 orbital, as is shown in figure 5 below. For a given system such as Earth, this figure 8 orbital is produced for all particles meeting the parameters necessary for them to physically pass through the body of the Earth and to be redirected back towards the center of gravity of the Earth afterwards. The summation of the flow of all particles around a given particle traveling in this manner produces what is known as an electromagnetic field, as is shown in figure 6. So there's just a bunch of figure 8 patterns here where each particle travels in its own figure 8, and the summation of all particles in this way we then observe as what we call an electromagnetic field. As this relates to a single particle's electromagnetic field, it is the most basic form. More complex forms, such as in the structure of magnets, come about from many particles acting as a single system, but not enough particles for their cumulative form to be particulate in nature. For example, as all the atoms of Earth become particulate in nature as a whole. This shows a case where the simpler system is the larger system between magnets on Earth and the Earth itself. This is an example of why the assumption that smaller inherently means simpler or more elementary is invalid. There are other considerations that come into play regarding the strength and detectability of the electromagnetic field of a particle. The first major influence is the spin of the particle. Whether or not the particle is spinning relative to its environment and to what degree plays a central role in the production of electromagnetic fields. In the instance where the particle is not spinning rapidly, such as in the case of Venus's slow rotation, it is possible for particles to pass through the center of gravity but not be redirected back towards the non-spinning particle. For Venus, its magnetic field is so weak that it is only detectable through observance of near Venus wake symptomatic of magnetic reconnection. In other words, we cannot directly detect it, but can know of its existence through observing phenomena associated with magnetic fields. This is because when a particle is rotating, it generates a bulge at its equator by its centrifugal force, inclusive of the disk of mass perpendicular to the axis of rotation of the particle, which leads to a gravitational imbalance in the direction of the plane of the bulge and disk material, so as to produce the necessary curvature in the flow of the particles passing through the center of gravity. Venus is known to be the most spherical body in the solar system, and thereby its electromagnetic field is not detectable. It is the curvature in the path of travel of particles that pass through the center of gravity that enables them to be redirected back towards the center of gravity of the rotating particle. If there is a perfect balance, so that the direction of the force of gravity upon the smaller particles after passing through the center of gravity of the larger particle is exactly opposite to its direction of travel, then it can continue to travel sufficiently away from the larger particle so as to reach a distance of separation where it is no longer greatly influenced by the gravity of the larger particle, as shown in figure 7. So when it passes through the center, if the balance of gravity behind the particle is balanced, then it will continue to go straight. Whereas if there's a disk structure, then there's a tendency from the gravity towards the disk, which causes curvature in the flow pattern, leading to a figure 8. And this is why rotation is necessary for electromagnetic fields. Greater rotation rates lead to greater bulges and disk structures due to the rotation. This, in turn, leads to more drastic imbalances in the direction of gravity acting upon the particles passing through the center of gravity in the direction of the bulge, and thereby, when a system is in rotation relative to its environment, it is capable of producing electromagnetic fields whose observed strength is a function of its mass as well as the degree to which the mass is pancaked by the rotation versus spherical due to non-rotation, as depicted in figure 8. So again, just the pancaking concept due to rotation leads to an imbalance in gravity towards that pancaking, which then leads to figure 8 orbitals, which is essentially a disk structure. Thereby, systems which rotate rapidly have more apparent and observably strong electromagnetic fields than those which rotate more slowly and have the same mass. As a result, non-rotating systems of nearly identical mass as a rotating system can generate very weak electromagnetic fields, whereas the rotating system is capable of generating an observable electromagnetic field. Such is the case for the very similar mass systems of Venus and Earth. Another important consideration in the outcome of the observed strength of the electromagnetic field of a particle, just like the sharpened pencil, is not just its mass, but also its density. Due to the inverse radius squared function of gravity, higher density systems also produce relatively stronger electromagnetic fields than lower density systems of the same overall mass. This is because when a given particle's mass is distributed widely in a large volume, the distance of separation of the bulk of the mass on particles orbiting in a figure 8 orbital is larger than when the same mass of the system producing the electromagnetic field is packed into a smaller volume. As a result, low-density systems are less able to influence the trajectory of an orbiting particle than higher-density systems of the same mass. The cumulative force of gravity of all of the constituent particles of the densely packed mass spikes more when the orbiting particle is near the center of gravity than in the case of a lower-density system. This leads to a densely packed system more drastically influencing the trajectory of the orbiting particles than a low-density system and having a stronger electromagnetic field as a result. Thereby, in the case of systems such as neutron stars, higher density systems produce observably stronger electromagnetic fields than lower density systems of the same mass. Therefore, gravity causes electromagnetic fields. This is particularly apparent because it so drastically reduces the fundamental mechanics of the universe, as we are not presently aware that electromagnetic fields are connected directly to gravity, that it necessitates that it is the case. Moreover, this non-trivial simplification of the fundamentals of physics by connecting two fundamental forces and beginning to show how one produces the other greatly supports the hypothesis that the universe is factually infinite. As a result, it strongly supports that there is no such thing as an elementary particle. Indeed, James Clerk Maxwell, in a treatise on electricity and magnetism, states, in several parts of this treatise, an attempt has been made to explain electromagnetic phenomena by means of mechanical action transmitted from one body to another by means of a medium occupying the space between them. The undulatory theory of light also assumes the existence of a medium. We have now to show that the properties of the electromagnetic medium are identical with those of the luminiferous medium. To fill all space with a new medium whenever any new phenomenon is to be explained is by no means philosophical. But if the study of two different branches of science has independently suggested the idea of a medium, and if the properties which must be attributed to the medium in order to account for electromagnetic phenomena are of the same kind as those which we attribute to the luminiferous medium in order to account for the phenomena of light, the evidence for the physical existence of the medium will be considerably strengthened. Gravity is hereby shown to pull this medium of infinitesimal particles physically through a given body so as to cause it to flow in a figure-8 orbital. This then is how gravity causes electromagnetic fields. All right, well, thanks for listening. I will rejoin with the next section here in my next video. Thanks a lot.